Okay, let's say we start with 4 distinct objects. So here n is equal to 4. These 4 people, Alice, Bob, Carol, and Doris. And let's say we want to find permutations of size 3. So 4p3, which we know to be 4 factorial over 4 minus 3 factorial. Or 4 factorial over 1 factorial, which is really just 4 factorial, which is 4 times 3 times 2 times 1, or 24. Let's actually take the time to list them all. So we could have Alice, Bob, and Carol and all of its permutations. So A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Or we could have Alice, Carol, and Doris. So that's A, C, D, and then all of those permutations, A, D, C, C, A, D, C, D, A, D, A, C, D, C, A. We could have Alice, Bob, and Doris. So A, B, D. A, D, B, B, A, D, B, D, A, D, A, B, D, B, A. And lastly, we could have Bob, Carol, and Doris. Bob, Carol, Doris, Bob, Doris, Carol, CBD, CDB, DCB, and DBC. And we can verify that's 4 sixes, that's 24, so we feel good about this. Now, what if instead I wanted just groups of size 3 from these 4 distinct objects? So I don't want to account for order. So if I want to find all groups, so groups unless you're assigning a position to the group, to a member of the group, groups are an unordered set. So find all groups of size R from n distinct objects is a combination. So instead of a permutation, which is accounting for order, a combination is an unordered set of size R from n distinct objects. And so how should we count those? Well, we know it's not 4 factorial over 4 minus 3 factorial, because that would give us all 24 of those. And we don't want 24. We really just want when A, B, and C are together, when A, C, and D are together, A, B, and D, or B, C, and D. And yet we're overcounting each one of these groups by a factor of all the permutations of those 3. So by a factor of every one of these is overcounted by 3 factorial. So we can divide out, we can start with the permutation and then just divide out, because the permutation does also separate the groups of 4 into groups of 3, and they just count all the permutations as well. So if we divide out all the permutations of each group, we get just the group, the number of the group, which we see as 4. So let's check that out. That's 4 factorial over 1 factorial, 3 factorial, which is 4 times 3 factorial over 3 factorial, because 1 factorial is just 1, and it is indeed 4. So a combination of n distinct objects taken 4 at a time is, we write NCR instead of NPR for a permutation. More commonly, we write N choose R. We say N choose R. And it is going to be, starting with our permutation, n factorial over n minus r factorial, that's our permutation right here. And then we're dividing out all of the permutations of each group. And that's a combination. So you want to ask yourself, in general, whether order matters or order doesn't matter. In the next video, we're going to look at 4 specific counting problems. We've already seen 2 of them here.